Hi, welcome to Algebra 2 Common Core. Tonight in our last lesson of this chapter, we're going to take a look at a new parabola equation. It's based on measuring the distance from the vertex to the focus. So the vertex is going to be an important part of this parabola equation. We're also going to have to take into account which direction our parabola opens. Up until now, we've only been talking about parabolas that open up or down. Today we're going to take a look at equations also that either open to the right or to the left when we graph them. So first of all, let's take a look at the definition inside the box. P is going to stand for the distance from the vertex to the focus of the parabola. When we have a parabola that opens up or down, we're going to use the equation x minus h squared equals 4p times y minus k. So you'll notice that for an up or down parabola, the x variable is going to be squared and the y will not. We're going to again use h comma k as our vertex. Now new for us is going to be the parabolas that open left and right. That equation is going to be y minus k squared equals 4p times x minus h. So you'll notice that for the sideways parabola, the y variable is being squared and the x variable is not. Again, we're going to use hk to stand for the vertex. So our directions for the first few examples: find the equation of the parabola using this p form that I've just introduced. Once we get that equation, sometimes we are going to have to rewrite the equation in standard form. It depends what the directions say, or if it's multiple choice, it depends on the form that the multiple choice answer is given in. Let's take a look at the diagram that's given in number 1. I see that I have a parabola that opens up. So since I have a parabola that opens up, I'm going to use the equation, the p formula, x minus h squared is equal to 4 times p times y minus k. So you have to make that decision first, which equation to use based on whether the parabola opens up or down or left to right. Now for this one, I can see that the vertex is located right here, and I'm going to read those coordinates from my graph. I see that the vertex is actually located at the point 1, 4. Now the other information that I need for this is the focus. This particular picture does not have the focus drawn in, but what's important to note for every single parabola is that the distance from the vertex to the directrix, which in this case seems to be 2 units because I'm going from 4 down to 2, has to be exactly the same as the distance from the vertex to the focus. So we're going to draw in our focus. We see that it's going to be located at 1, 6. That's going to be our focus. Now it's actually not necessary that I use the coordinates for the focus. I need the coordinates for the vertex. What is necessary is that I can read the p-value, the distance from the vertex to the focus. So in this instance, I'm going to say p is equal to 2. I'm going to call it a positive 2 because to get from the vertex to the focus, I have to go up. I'm just going to enter this information into this equation. So I will have x minus the x coordinate of the vertex, square that, equals 4 times the p-value, 2 in this case, multiplied by y minus the y coordinate of the vertex. So again, we're looking at the vertex coordinates right here and right here. Now, a couple things to note. First of all, last week when we saw the vertex formula of a parabola, we remembered to always take the opposite sign in the x parentheses to get the x-coordinate of the vertex. But the y-coordinate, we always took the same sign. But that's because that number was never written next to the y. However, when it is written next to the y, we're going to do the same thing that we do with the x's and take the opposite sign. So we can see from this equation that the vertex is 1, 4. This equation also tells me, based on this coefficient here, that the vertex and the focus are 2 units apart, and the focus is above the vertex. Now, to finish off this problem, we're going to go ahead and multiply everything out. So I'm going to say x minus 1 squared is x squared minus 2x plus 1. On the right side, 4 times 2 is 8, so we're going to multiply 8 times y minus 4. Let's distribute that 8, so x squared minus 2x plus 1 equals 8y minus 32. Add the 32 to the left side, so x squared minus 2x plus 33 is equal to 8y. And again, the only reason I'm multiplying all this out is because the directions said put our answer in standard form. So we're going to solve for y. Let's divide every term by 8 on the left and the right. So in standard form, this would be y is equal to 1/8 x squared minus, let's reduce that fraction, 1/4 x plus 33 over 8. And that would be the answer for our standard form for the equation of the parabola given in the diagram. Now let's try example number 2. You'll notice that this parabola is a sideways parabola. So when it's a left-right parabola, that means that I have to use the basic equation y minus k squared equals 4p times x minus h. So first decision, which equation do you use based on which way the parabola faces? This one is left-right, sideways, so I'm using the equation that begins with the y squared. Now the next thing I'm going to look at is on my diagram, what's the vertex? I see that the vertex is the point -4, 2. So that's going to be my h and my k for my equation. Last decision, how far away is the vertex and the focus from each other? I see that the vertex is at -4, 2, the focus is at -5, 2, so that means that my p-value must be 1, but it's going to be a -1 because I have to go to the left to get to the focus. Let's go ahead and put all this information together in my equation. So y minus, now make sure you're using the y coordinate of the vertex. So y minus 2 squared equals 4 times the p-value -1 multiplied by x minus the x-coordinate of the vertex. So let's go ahead and multiply this out. So I've got y squared minus 4y plus 4 equals -4 is going to multiply by x plus 4. So y squared minus 4y plus 4 is equal to -4x minus 16. Let's add 16 to both sides, so y squared minus 4y plus 20 equals -4x. So again, you can see how important it is to be able to move back and forth between 2 or more different forms of a parabola equation. Let's divide both sides by -4. So I've got x is equal to -1/4 y squared plus y minus 5. Now, see the big difference here is when I have a parabola that opens sideways, I'm going to have an equation as in x equals rather than a y equals. We also note that this kind of parabola is not a function because it doesn't pass the vertical line test. Let's look at example number 3 together. This time I have a parabola that faces down. So a down parabola is going to be my equation x minus h squared equals 4p times y minus k. Look at the vertex. Ooh, this is a nice easy one because I see that my vertex is just at the origin. So 0, 0. That, of course, is going to be the h and the k in my equation. Now, this one also, I guess it does have the focus drawn in. Here's the focus right here. So I'm going to count and say how much is there between the vertex and the focus. So clearly there are 6 units. Because those 6 units to get from the vertex to the focus are going down, my p-value is going to be equal to a -6. So let's go ahead and enter all of this information into my equation. So x minus 0 squared equals 4 times -6 multiplied by y minus 0. And this is a nice, easy equation. X squared is equal to -24y. In standard form, divide both sides by -24, so y is equal to -1/24 x squared. And again, you should recognize that when the x is the variable that's being squared, my parabola is going to open up or down. When I've got a negative coefficient in front of the x squared, that tells me the parabola is going to open down like a frown. For the next group of examples, we're not given a diagram, but it's going to be necessary to draw a sketch of the information that we are given so that we'll be able to find our vertex and our value for p. So make sure in your notes you are drawing a sketch for each of these examples. So I've got my axes and I'm going to find the focus this time. The focus is located at 5, 6. So count that off, draw a point at 5, 6, and mark it F for focus. Now, for this example, the directrix is the x-axis. So that means this line right here, the x-axis, is my directrix. What's not given to us this time is where the vertex is. Well, let's think about this for a minute. We know that the vertex has to be halfway between the directrix and the focus. So if the focus is all the way up at a height of 6 and the directrix is at a height of 0, let's go halfway between and let's go to a height of 3. The x-coordinate will be exactly the same as the focus x-coordinate. So here's my graph of my parabola. So we said, let's see here if we can count that out. Our vertex has to be the point 5, 3. Now if you have trouble with that, you might want to get some graph paper and plot this on graph paper so that you can count the boxes. Now how about my p-value? To go from the vertex at 5, 3 to the focus at 5, 6, p must be equal to 3. So that's a positive 3 because the parabola opens up and because I have to go up to get from the vertex to the focus. Now this is an up and down parabola, so that tells me I'm going to do x minus h squared equals 4p times y minus k. Let's substitute these numbers in. So x minus the x-coordinate of the vertex, square that, equals 4 times 3 times y minus the y-coordinate of the vertex. So x minus 5 squared equals 12 times y minus 3. Now you'll notice that the directions said that we could leave our answer in the p form, so I'm going to leave my answer just like that. It didn't ask for standard form, so I stopped there. Let's try a couple more together. For number 5, draw the sketch. I see that I've got a focus of 3, 7. My directrix this time is going down below the x-axis, 3 below, so I'm going to make that directrix right about here. And that's the equation y equals -3. Now, where's the vertex going to be? If I count to go from -3 up to the x-axis, that's 3. And then to go from the x-axis up to the focus, that's 7. So altogether I've got 10 boxes in between. Half of that is going to be 5. So from the focus, I'm going to go down 5 and say that the vertex has to be located at 3, 2. And again, if some graph paper would help you, go ahead and draw it on graph paper. There's the parabola. So hopefully you're seeing that this form is a lot easier to use than our locus definition. But sometimes on the Regents exam, they're going to ask you to specifically use that locus definition. If you're not specifically asked for the locus definition, you can use any appropriate form. Now this again is an up and down parabola, so we're going to use x minus h squared equals 4p times y minus k. So this one, let's see, we said our p must be how far it is from the vertex to the focus. That was that halfway number, 5. So I'm going to say x minus 3 squared equals 4 times 5 times y minus 2. And again, I don't need to write this in standard form, so I'm going to stop with the form x minus 3 squared equals 20 times y minus 2. And there is my p form of the equation. For example number 6, I'd like you to pause the video for a few minutes and draw a sketch of the information that you're given. Try to identify the vertex and also identify what your p-value is. And then we'll come together and go back over what the equation is going to be for this one. Okay, take a look at my diagram and see if yours matches. X equals 4 is a vertical directrix. So we want to make our focus at -6, 2, and then identify the vertex, which is going to be halfway between the focus and the directrix. So if you count all of the units between the focus and the directrix, there's 10 units altogether. So let's go halfway, let's go 5 units. And draw the vertex. The vertex is going to be at -1, 2. So since I went 5, that tells me that my p-value is 5, and in this case it's a -5 because my parabola is opening left, and because to get from the vertex to the focus I have to go left. Now this equation is going to be the one that's a sideways parabola, so that's going to be my y minus k squared equals 4p times x minus h. Okay, go ahead and substitute those values in. So y minus, now let's make sure that we're using the y coordinate here of the vertex. Y minus 2 squared is equal to 4 times the p, so that's going to give me -20, times x minus the x coordinate of the vertex. So x minus a -1 is x plus 1. So that gives us our answer for the parabola, as shown here. And again, remember the y is being squared because I've got a sideways parabola. Now I'd like you to pause the video and do problems 7 and 8. When you come back, you can check your work with my solution and make sure that you got the same equation that I got. Okay, let's look at problem number 7. With a focus of 3, 2, and a directrix of y equals 8, we see that this has to be a parabola that opens down because the focus has to be on the inside of the parabola and the directrix has to be on the outside. Find the point that's halfway between the focus and the directrix, so that's 3, 5. And the vertex to the focus is 3 steps, so we're going to put a -3 as that p-value. So my final equation for this one, x minus 3 squared equals -12 times y minus 5. So check your work over and make sure that we match. Number 8 looks like this. I have a focus at 4, -2. I've got a directrix at x equals -6. go halfway between, and I get that my vertex is happening at -1, -2. If I count over from the vertex to the focus, I see that the p-value is 5. It has to be positive because the parabola is opening to the right, and I have to go from the vertex to the focus in the right direction. So my final answer for this one should be y plus 2 squared equals 20 times x plus 1. Now we've had some very good practice with parabolas in the last few days. It's going to be very important for us to be able to go back and forth between all the different parabola equations. So practice with this kind today. We'll be doing some more work in class, and have a great night.